In this video, we're going to be talking about boiling, we're going to be talking about vaporization, we're going to be talking about evaporation, and we're going to be talking about something called vapor pressure, which is a property of evaporated vapors. You are going to need your notebook, you're going to need something to write with. Once you have those ready, let's go. Okay, so the first thing I should probably do is start off with a few definitions, right? So, as we've said in the previous video, and as I went over with you at the beginning of the year, the name of the phase change when you go from a liquid to a gas is called vaporizing. It is not called boiling, even though it happens at a substance's boiling point. Evaporation is different than vaporizing because evaporation is a surface phenomena. Vaporizing is when the entire sample changes over from liquid to gas. Evaporation is when the molecules on the surface of a liquid have gotten enough kinetic energy so that they can break free of that liquid state. They can break their intermolecular forces, jump up, and become a gas. Now, the thing about evaporation is that evaporation can happen at any temperature higher than the melting point of the substance, right? So water will evaporate at any temperature higher than 0 degrees Celsius. It's just that the higher the temperature is, the quicker evaporation will occur. Now, another thing we're going to go over is what's called vapor pressure. Vapor pressure is when you have this evaporation occurring and you form a gas. The vapor pressure is the pressure of the gas you form from that evaporative process. Now, the interesting thing about vapor pressure is that the only thing it depends on is the temperature of the sample. Right? Doesn't matter how much of it you have, it's just the temperature of the sample. That will tell you how much of it can turn into a gas, how much can vaporize. So what I have here is I have coming up on this slide an example of vapor pressure. Right? So in the diagram on the left, what you see is that some of the molecules on the surface of the water in that flask have enough energy they can jump up and become a gas. And when they do, they bounce all around the inside of that container, and as they strike the wall of the container, they exert a pressure. And the pressure you can measure as a function of temperature using the graph on the right. Now, thing to keep in mind, the stronger the intermolecular forces, the lower the vapor pressure, because it becomes much harder for a substance to separate when it's strongly attracted to its other molecules. Right? So water, because it has strong hydrogen bonding, has a very low vapor pressure for its temperature, right? Much lower than that of ethyl alcohol or ether, which they mean dimethyl ether when they talk about it. Right? Ethyl alcohol does have hydrogen bonding, but it's less strong than that in water. So that means that because it has less strong attractions, it's easier to become a vapor. So its vapor pressure is higher because you notice that the pressure that they give you is higher at every possible temperature for our green alcohol line. And ether, because ether is just polar, it's not hydrogen bonded, it's relatively easy for ether molecules to break away from their liquid and form a gas, so they will form a very high vapor pressure. One of the things about vapor pressure that's kind of interesting is the higher the vapor pressure of a liquid, the more volatile it is. Right, so this is vapor pressure. If we haven't covered gas laws with you yet, we'll be using this a little bit more when we talk about gas laws. If we have covered gas laws already, we're going to start using this a little bit more in some of the later videos in this chapter. All right, so that is what vapor pressure is, just the pressure exerted by the molecules that have evaporated from a liquid. Now, this is where it gets us into boiling. The definition for boiling is when the vapor pressure of a substance equals the atmospheric pressure of all the air pushing around it. Okay, so for example, water. To get to 1 atmosphere pressure, which is normal atmospheric pressure, water has to be at 100 degrees to get its pressure that high. That's why water boils at 100. Below 100 degrees, it has a lower vapor pressure, so it's not boiling. Ethyl alcohol, because ethyl alcohol has a higher vapor pressure normally, it vaporizes a lot more easily. It takes less heat to get enough alcohol to vaporize to hit that 1 atmosphere mark, and reach the boiling point. And this, by the way, is what we call normal boiling point, because normal boiling point's at 1 atmosphere. Boiling is affected by whatever the atmospheric pressure is around it. That's why if you've ever seen directions when they say, like when you're cooking food, the package says at higher altitude do this. The reason why is because when you're at a higher altitude, there's less air pressure around you. And since there's less air pressure around you, water boils at a lower temperature. And if it boils at a lower temperature, you need to cook it longer in order to give it the same amount of energy in order to affect the cooking process. For those of you who are moving on in the next video, we're going to be talking about properties of solutions that exist as a result of their concentration. Otherwise, that is going to be it for chapter 14, and I will see you in class.